Welcome back to the breadboard. I just recently received a preview of release 2.1.3 of the upcoming firmware for the IOT2020 from Siemens. This is an industrial gateway controller type device aimed at the educational and small industry and hobbyist maker kind of market. Up to now we've been at 2.1.2 and there were a few little problems with this. So what we're going to do is we're going to have a look at what's new in the software, run a few tests and see if it all works and if we're happy with it. This should be a good release. I've been working with Siemens quite closely and RS Components to get a few things fixed. So let's start working our way through and see what we have. So what are the features that we have in 2.1.3? We have an IOT2000 setup, which is a utility allowing you to configure the applications and some of the parameters for the Mqtt Linux that's running. We had Node-RED pre-installed, NPM, Node.js, Mosquitto and SQLite 3, and these are the versions we have for each of them. So Node-RED is with 2.1.3 is sitting at 15.2, NPM is 3.10.9, Node.js 6.92, and Mosquitto 1.4, and SQLite 3 is at version 3.1. So these are not the latest versions, but they are a good stable place to be with the applications. So after downloading from the Siemens website the new image, and I've got previous videos on that, so I'm not going to bore you by showing you that now, and we burned it onto an SD card, popped it into the IOT2020 and powered it up for the first time. What do we see happening? Well, we've got the file system on the SD card is automatically resized to the entire capacity of the SD card. It used to be that you did this manually. Now it's done automatically for you. In my case, I used a 64 gigabyte Sandisk Ultra card, which has about 80 megabytes per second read and write speed, so it's quite fast for the IOT2020. The network defaults to 192.168.200.1. For me, that's a bit of a pain because none of my networks at home here are on that subnet, but I do have an FTDI cable, so it's easy to change it. If you don't have an FTDI cable, then you can simply change your local network temporarily to be on the same subnet, connect to the IOT2020 through SSH and using PuTTY or something, and then you can just reconfigure it that way. Either way, the process to reconfigure it is the same. We have Node-RED and Mosquitto pre-installed now. They're set for manual start by default, and there's no security configured. And by security, what I'm referring to is passwords and things like that, HTTPS, root logon and things. We're not looking at this from an industrial situation, but more from an educational perspective. So it pays to have it open to make it a little bit easier for a student, a maker, etc., to be able to get started with this. As they become more experienced, of course, and if they want to deploy it into an actual application where it's running your home, small office, whatever it may be, then you will of course want to add some security measures back into this. We're not going to cover that in this video. We're just going to leave the security measures as they are. We have an SSH server enabled by default, and of course this is necessary if you don't have an FTDI cable, so that you can connect to the IOT2020 over the network. Its host name is set to IOT2000. Now I'm not going to change this, but obviously if you're using multiples of these or you have some naming convention for your environment, then you can easily change this to suit that. The root user password is not set, and the root user is the only user that's basically configured here for login at the moment, and you can go in and add other users of course, but again, this is not part of this video, and it's a fairly common thing with Linux anyway to be able to do that, so I won't try and show you how to do that here. There have been a few fixes in this release. So previously in release version 2.1.2, Node-RED wouldn't start up correctly and would start copying some user files and modules into the root directory of the folder structure. This was a very simple thing to fix, and Siemens have done that. There was a bug with the serial port under Node-RED where if I had upgraded Node-RED it would break, and that's now been fixed, which is great. Mosquito Broker was not installed by default, and if you try to install it yourself it would go in, but it would take an awful long time to compile and install and everything else. So now it's completely installed for you with the image, so that's going to save a lot of time and make it easy to get started with your own local applications. There's also been some updates to the IOT2000 setup utility to include management of the new applications and things like that. We'll have a look at that in a moment. The apps that are included, that includes Node-RED and Mosquitto, SQLite 3, etc. They're not the latest versions, but they are stable versions, and they do all work just fine out of the box. So unless you've got a good reason to upgrade them, you don't need to. All right, I will be upgrading them in my installation because there's a few things that I think I may need them for. So for my setup, what am I going to do? I'm going to change the network to use DHCP. That way it'll just pull one off of my router and use its IP address that it gets assigned to. I'm going to change Node-RED and Mosquitto to auto start. It will need a reboot after that to actually boot up under system control versus user control, and there is a difference sometimes, so I want to just use the reboot to kick it off the first time. I'm going to leave the host name alone, and I'm not going to change the root user password either. So this is a PuTTY session connected to COM18, which is my FTDI cable. It shows up on my computer as COM18. I've logged in already. You just put in the username and no password by default, and the username being root. And if I run IOT2000 setup, it will bring us up the little text-based configuration utility. Let's just have a quick look through here and see what we've got for this version. So we've got the OS settings. We'll go in there. You can change the host name, and this is where you can change it from IOT2000 to something else. I'm going to leave it alone just for now, but that's where you change it. We can change the root user password. Now I'm not going to go into here because sometimes it messes it up a little bit if you go in and it starts. Actually, no, it shouldn't. Let's just go in and have a look. Yeah, it's shouldn't have done that. It's asking me for the password. I'm just going to break out of it if I can. So that's OS settings. The next section here is networking, which is one of the areas that we're interested in. We can configure the interface, which is the only option here, and it currently says DHCP because I changed this before, but where it was at initially was with the IP address 192.168.200.1. So just going in here, changing this to lowercase DHCP, pay attention to that. Linux is case sensitive and it won't work properly if you type in uppercase DHCP. So just type in DHCP and then OK out, and it will set it for DHCP for you. So that's that done, ready for reboot, and then it'll pick up a network address. The last area is software. So we'll go in here. We have a package repository, which is where if you were using OPKG package manager and you wanted to point to some repositories, you can just enter a host address right in here, or you can just go in and edit the file directly if you wanted to later on. Just going to escape out of there. You can manage the packages that are already installed, and what we've got is Galileo software, Node.js, and TCF agent. Now I'm not going to undo any of these. This press spacebar to select these will actually remove them, and I do not want to do that, so I'm just going to escape out of here. And what I want to do is manage the auto start options, and by default in here what you would normally find is that Node-RED is off, Mosquito Broker is off, and SSH Server is enabled. What I've done is I've just enabled these other two and hit done. Now we've done everything that we can do. Let's go to quit. We're back to the main menu of the IoT setup. So we'll just go to quit here, and now we're done. And what I would normally do is a reboot here, just to kick everything off. So booting up Node-RED, booting up Mosquitto so that they're running for me with their default configurations, etc., etc. So I'm just going to let this boot up. I'm just going to pause the screen capture for a moment, and then we'll come back to it. Okay, now we've booted up and it's prompting me for login, so just simply type root, and now it's asking me for a password, but it's empty, so I'm just going to press enter again, and there we are back in again. Now if you want to know whether Mosquitto or Node-RED is running, you can do things like ps-aux, pipe it through grep and ask for something like mosquitto star, and it should tell us if Mosquitto is running, and there it is. It is running indeed right there. You can do the same thing for Node-RED if you like. So we'll do that for Node-RED. We'll just say node star, just capture anything with Node-RED. So there we have Node-RED up and running as well, right there. So there we go, Node-RED is up and running and Mosquitto is up and running. Now you can also run natively some Arduino sketches, or you can use Eclipse and upload C++ applications into the IOT2020 as well. We're not going to look at that in this video. We're just going to look at using Node-RED for IoT, because that's something that is very easy for a lot of people to do and is very popular on a number of different platforms. And the whole purpose of this with the upgrade to 2.1.3 is to get all of the Node-RED features and support applications up and running nice and easily. So we're just going to continue from there. Now you can verify the current version of Node-RED, npm, etc. by simply running an npm-g outdated from the command line, like I've shown here. I'm not going to run it again right now. It does take a little while to run because it goes trolling through all of the file system folders under Node-RED looking for modules that it needs to report on. As you can see here, we've got fairly up-to-date modules, but they are they are not the absolute latest. So anyway, we want to upgrade these, but what I want to try and avoid initially is upgrading the serial port module, because this is the one that I found was giving me problems before. And if I do upgrade it, it's a pain in the butt to get back to what was there before, and it takes quite a few hours of installations and things after these upgrades to redo it all just so that I can avoid it. So I'm going to avoid it till the very latest, and I'll make a backup of my SD card before we go. Before we upgrade though, I want to test the functionality with the basic build. So what I'm going to use is Node-RED. This is showing you the flows that I have. This first flow is an initialization flow. It initializes the TTY-S0 serial UART on the board to connect to the Arduino TXRX pins D0 and D1. The second area here is for the actual testing. So this is just a 1-second timer that keeps pulsing every second, causes a read from the user button that's on the outside case of the IOT2020, and if it sees a change in state, the RBE only, limits it to only changes in state. It will invert whatever it reads and then feed it out on D4. There's a little delay, and then it feeds it out on D7. Another 1-second delay puts it out on D8. Another 1-second delay puts it out on D12. Now, the reason for this is just to 1-second interval. As long as I'm holding that button pressed, it's going to start turning the relays on the Arduino relay shield that I have connected. Now, really, because the relays are inside boxes, you can't see them moving. I'm not going to bother trying to show you the actual relays because you're not going to see anything. But we will test this. You may hear it as it's going through with the clicking. The other 3 areas here are for testing the serial port. So TTY-S0, 2 of them in this case, are the Arduino header TXRX pins. TTY-S1 is the debug port that is actually connected to my COM18 at the moment. So I should be able to send data out to it, but because it's configured to be the console, it won't let me feed data right back in again on this one, back into the TTY-S1. If I turned off the debug console, then you would be able to use it normally. And then the last one is actually the USB connection that when you plug in a micro USB cable to do things like uploading an Arduino sketch that's the one that you would get, and that's the COM port that would show up there, and you can also talk to that as well. So pressing the button to the left of these bluish modules will initiate a signal. So in the case of the one connected to the Arduino headers, it'll send the string hello. In the case of the other two, it'll just send the current timestamps. So this is the configuration here. I've got the relay shield plugged in. I've got the 3D printed lid that I made, just protecting most of it. You can see these extra headers that are on the relay shield poking through. And then the Arduino headers here are poking through the top of the case. And I'm just looping back D0, D1, which is the transmit receive pins, so we can test the loop back there. The cable over here is my FTDI cable connected to the debug port. And note the other thing here, which is not standard in an IOT2020, is a little Panasonic battery to keep the real-time clock that's on board up and running. The USB on TTY GS0 is this socket right here. It is not the big USB host port, it's the small client port right here. Here are the results. I just did a quick screen capture, but in fairness, I will show you this working right now. So these are the two initialization routines, the timestamp and the inject. You can see this one, all it does is a one-off at the startup, and this inject here does the same thing. It just does a single pulse on startup. I could use one and connect it to both of them, I just happen to not. The first script here, what it does is it executes a shell script that I have on my home folder for root user, and I'll show you that in just a second. You can see what it does, but basically it talks to the multiplexers on the IOT2020 and reconfigures the serial port of the Quark processor to go out to the header pins of the Arduino. The second part here is using a direct echo to the file system to enable the user button that's on the outside of the case so that we can read it. So let's just have a quick look at that shell script just so I can show you. And here it is, tty-so setup.sh. And you can see all it is a bunch of echo file system commands setting up some pins to change the multiplexer settings so that we can have those. The second part of this test, there are some other tabs on here, but I'm not going to go through those right now, which is right here. These will allow us to inject signal. So right now there's a 1-second timer reading the user button, and the RBE, what that basically does is whatever signal comes in, if it comes in again with the same value, it won't come out the other side of it. So it's a basically route by exception. So now if I push the button, I'm going to be quiet while I do it so that hopefully you'll be able to hear the clicking of the relays. Now I let go of the button. And that's that. So that's basically all it does. It just clicks the relays on and then off in sequence as long as I'm holding the button. The next one, which is the TTL serial, this is the one with the loopback connector. I do have a lot of other things going on here right now, so I will have to do this quickly. But if I click the hello button here, it should echo back. Looks like the text is getting a little bit corrupted for some reason. Every time I've used this before, it's been quite happily working. Let me just check the other two for a moment. So this one is the, if you look at here, there's nothing at the bottom here right now. I'm going to click on the one connected to TTY-S1. It'll disappear for a moment, but I'll bring it back again. So I'll do it 3 times, and we should see 3 timestamps show up here, just chained together. So that's 3. Now let's go back to that window, and there are the 3 timestamps that have shown up now on that screen. Now if I click on this last one to GSO, the same thing will happen. I won't waste your time by showing you the exact same basic thing again. I haven't figured out why right now I can't write back to this one. It might be to just simply do with my UART configuration or something like that, so I'll have to investigate that. But I can send data out of here. I can loop back here, which was the whole point in the bug that we had earlier. So that's basically showing you that everything is working. Now what I've also got in here are some additional modules that I've loaded. I've updated already in this case the dashboard to the latest version, which is giving us the color picker and a few things like that. By default, you do get dashboard loaded. It's just an earlier version, so there's a couple of these modules that are not included. The Intel GPIO is there by default and works just fine for all the different outputs. In fact, I'm using some of them up here for this. The Modbus I've added so that I can talk to my FLIR AX8 thermal imager, and that installed just fine, but I had to do the Node-RED update first, or npm and Node-RED. Big Timer is from Pete Scargill, one of my friends. He does a lot of work with Node-RED, and this is a great timer for all sorts of things. Everything else is fairly standard. I've loaded some I2C nodes as well. I haven't tested them yet. They certainly don't break anything, but I haven't tested them to see if I can actually talk to some I2C devices. And I have some subflows, but all of these I'm going to talk about in another video. We just want to make sure that the basics of this 2.1.3 is all up and running and working nicely. So the next thing we want to test is actually using Mosquitto. So I've already mentioned that it is included, but we haven't tried it yet, and it wasn't in the previous version. So let's have a look. What we're going to do is we're going to set up a little bit of a flow in Node-RED using a MQTT out and an MQTT in node. We're going to configure them as I've shown here. You can pause the video if you want to have a more detailed look at this. And we're also going to use an external application called MQTT Lens, which is a Chrome app, to fire messages from outside and also subscribe to outside messages as well, just to make sure everything is up and running the way we want it to be. So first things first, we've got to get the application built within Node-RED. So let's just go in here. We'll go back to our Node-RED that we're using. I have it already built here. Basically, we have a event button, which is this inject node. And I have it configured to simply send out a payload that says MQTT test, and that's it. I haven't bothered specifying a topic here, although I could. And our output one is configured to this is the local IP address of the IOT2020, and it's using the default port. I've given it a topic of just simply test, and I've not set any other properties, no security or anything like that, no username or password. It's just basically that setup. On the MQTT in node, we basically have the exact same configuration. You can actually pick the same MQTT broker from the drop-down once you've configured one. We've set test as the topic again, and this is running with a QoS of 2. I'm not sure why I set that to 2. I don't think I set it here. No, I didn't. I think that might have been just the default behavior. I didn't bother changing it. Anyway, the idea is that when I click here, it's going to publish to the MQTT broker the text MQTT test, and it's going to send it to a topic called test. This one is subscribed to that same topic, and so it should come in and show up in the message payload. And because I have this debug catch node here, it should show up in this debug window here. So let me just clear that, and then we'll just test this now. There's other things going on too, but there it is. There's the MQTT test coming amongst other things. There it is, going away nicely. And so that's showing that internally it seems to be working okay. Now let's go to externally. We'll fire up MQTT Lens, and we will configure this to do the same thing. Now this is, remember, the settings I had from a previous session, but basically when you fire up MQTT Lens, you give it a connection in here where you tell it a name, its IP address, which in this case is 1.142. Now I'm running this on my PC, so it is a separate device on my network. The client ID doesn't matter. You can generate a random one, that's fine. It just keeps things isolated. No username or password, no last will and testament or anything like that. Just save changes. If everything is correct, then you should get a little green circle saying that it is connected, and if you hover over it, it actually tells you it's connected. Now we want to, let me just clear out all of this stuff down here. So what we want to do is we're going to subscribe to this instance, and we're going to give it a topic of test. This is for a subscription. We want anything that's got that topic. So we just click subscribe and we're done. Now for publishing, we're going to publish to test as well. And we're going to say hello from MQTT Lens. All right, so if I hit submit here, if I hit publish, it should show up in the debug window of Node-RED. So let me just bring that up again right here. Let me just clear that off again. So if I go back to my MQTT Lens, I'm just going to keep this over here so that we can still see what's going over the right hand side. All right, and now if I actually click publish now with this one, you'll see it's came right into Node-RED, which is perfect. It's also, because this is also subscribing to the same topic, it's also reading it. Now if I go over to here, I'm going to lose this one just for a moment, but if I go and hit this test now and do it 3 times, let's say, go back to MQTT Lens, there it is, MQTT test, MQTT test, MQTT test, 3 times. Works just a treat. Now we already knew that MySQL was working from before, and in a future video not too long away I will be setting up a trending database and things like that to show the SQLite in action from Node-RED, so I'm not going to show it right here. I have used it in previous Node-RED videos, but just to keep things going, we wanted to really look at the fixes and additional bits and pieces in 2.1.3. Now, for all of the flows I've just shown you and some of the other ones that are on here, I will put them onto my either on Bitbucket or on GitHub, so that you can pull them down and try them out on your own if you want to, or at least just have a look at them. They look a bit weird when you see them on GitHub because it's just a great big long string of text. So before I leave Node-RED here, I just wanted to show you one of the things that I'm going to be going through in a future video, just to give you a bit of a teaser. What I have here, this is the Node-RED web interface using the dashboard nodes. And I have a number of things here configured. For instance, a weather station. This is saying it's my weather station in the backyard. It's not physically out there yet, which is why it's a little warmer. It's close to 0 outside, actually, not plus 25 degrees. The temperature sensor is actually just right near me. A power monitor, which is measuring mains voltage and current and things like that. A Sonoff power switch, which also has a temperature and humidity sensor connected to it, and a FLIR AX8 thermal imager. Now this image here is a snapshot from the thermal image taken live straight into Node-RED and displayed within it, and it's also showing point values that have been set up on the image within the imaging software. If I go to the live view, it'll actually bring on the points, right? These points here. Now this is still inside Node-RED, and one of the things that I can still do here is say point 3, which is spot 3, which shows 22.3 degrees right now. Let's take it to a cold spot. I think that should probably do it. Drop it down there. So spot 3 should now drop from 22 to like 20 or something. Anyway, so this is live use of a FLIR. There you go. Just went FLIR AX8 using Modbus protocol, talking to it over the network, pulling in live images, including a live stream, which is what you're looking at right now, and showing it on a screen. And I can even, from the other one, just clicking this, I can actually go directly to the camera and control it from its own app as well. This is the web interface that's provided by the AX8 camera. Anyway, I'm not going to go into the details of how I implemented any of this right now. I just wanted to show you that it can be done, and that I have the IOT2020 using Node-RED and Modbus talking to an industrial thermal imaging device, the FLIR AX8. So that's kind of cool for future. Anyway, enough of that. Let's get back to the PowerPoint. Updating, yeah. I mentioned that we were going to update things. So I'm not going to take you through the boring process of watching the screen scroll up and just give you things like this here. But I will talk you through what I did though. There were a few things that were out of date. When you run npm-g outdated, it looks at all of the globally installed nodes and tells you what the current version is and what you want they want to have and what the latest version is. So here we haven't done the update yet. I run an npm install npm -g for global install, and what that'll do is it'll go away for a while, and it's like tens of minutes or so, and it will update npm. Now I do it this way because from an early version like 3.10, I don't think you can go as an upgrade rather than an install of npm without it crapping out, because it's actually using npm to do the update as well. So by doing the install, it avoids the issues. Anyway, after running this, it takes it all the way up to version 4.4.4, which is the latest version. I'm not sure why it says it wants 4.5, but the latest version is 4.4, and that's what it installed perfectly well. No errors, no nothing. I then updated the Node-RED dashboard, which is the module within Node-RED. Let's just quickly show you that. This is the dashboard here, and on the left hand side there are a bunch of nodes down here called the dashboard, or just dashboard. All these buttons, drop down switches, sliders, text inputs, date time pickers, color pickers, gauges, charts, audio capability, UI control, etc. All of these are part of the Node-RED dashboard components, and they allow you to create the web pages that I was just showing you, like these. These are all using the dashboard components. And if I look at the weather station, this is using text boxes, and this is actually a gauge that Pete Scargill came up with. Him and I collaborated on creating this, although he did most of the work. That gives us a really nice, pretty gauge that you can have 2 pointers and other fun things like that. So look at his website for details on that. You know, power usage, these charts here are being driven from native Node-RED dashboard components, the chart components, and you can see they just do graphing, etc., etc. All well and good. So that's one of the things that we updated when we were going through that. And when it was completed, we now had 2.3.6, which, as you look over here, that is the absolute latest version. So that's great. We then did an update to Node-RED itself. It did give us a few errors, but at the end of the day, when I rebooted and tried all of the tests that we had ran before, they all worked perfectly well and at exactly the same level of functionality as we had before. Only difference is now we have a later version of Node-RED, you know, with bug fixes, whatever else might have been included in there, and there are a few extra management capabilities within Node-RED because of that as well. So I think that pretty much completes everything. Yep, that's the end of my PowerPoint. Back to basics. We have a new version of firmware for the IOT2020 about to come out. It's not yet been released. I just checked about half an hour ago. It wasn't there yet. 2.1.3 seems to have all the bugs fixed. It includes Node-RED, Mosquitto, SQLite 3, a couple of nodes for Node-RED, namely a dashboard and also some I/O nodes that support the IOT2020, which is the Intel GPIO modules. We've tested those, and we saw that they worked by switching the relays on and off, and also looping back on the serial port and things like that. So that's all well and good. You've seen the UI that allows you to configure some of the applications, turn them on and off, change the host name, change the serial, change the IP address and things. So I think we're all good and done. So I'm going to finish this video here. It's getting well past half an hour long already. And in the next video, we're going to start looking at having Node-RED configured to talk to edge devices, a weather station, which I'm going to be making a video on how I made the weather station, and also talking to the FLIR AX8 using Modbus, as well as some other HMI type of devices, all communicating to the SIMATIC IOT2020, because this is, at the end of the day, designed to be a gateway device for IoT. Fundamentally, you can use it for I/O, but you have to add add-ons to it to be able to do that. The I/O that I'm going to have primarily working with this, of course, are either wirelessly connected or network connected devices that are remote to the actual IOT2020, which is what it's really all about. But at the end of the day, in an educational home maker kind of environment, you will get it to do whatever you need it to do for your application. I just want to show you how to do a bunch of things and the fact that it is actually not that difficult to do them. Anyway, hope you liked the video, and I will see you soon. Bye.